All right, statistics. We're looking at data collection and experimental design today in this lesson, lesson 1.3, data collection, experimental design. Now, if you go to your question help, you can access the textbook. And here's a textbook. It gives a description of all the terms and things we're going to be looking at. One thing you got to look at right here are these guidelines. When you are doing a study, it's important that you follow these guidelines right here. Identify the variables of interest and the population of the study. If you're doing a statistic over the school, you need to identify that the school population would be maybe the students of the school, whether it be the high school or it be the middle school or the elementary school or all of them. You need to identify the variables of interest and the population. The variables of interest might be like the school lunch. Is that what you're looking at? Or are you looking at their study, how much their studies are getting completed? Number 2, develop a detailed plan for collecting data. Collecting data, that's one thing we're going to look at in here. It's important to collect data appropriately for your study. If you use a sample, make sure the sample is representative of the population. Then number 3, you collect the data. Then number 4, you describe the data using descriptive statistics techniques. Number 5, you interpret the data and make decisions about the population using the statistics. And that's what statistics is for, is to make decisions that will benefit society. And then the last one here, identify any possible errors that you could have. Because it's possible that you make an error that would make the information not feasible. Okay? Now, this is the next page here. This is page 18. This is distinguishing between an observational study and an experiment. Now, I've got some notes here wrote down, and I'll try to send you a picture of this. But an observational study versus an experiment. Okay, an observational study, the key thing here is observe. You're just observing something. There's no treatment. So like you have a person here that you're observing, and you're watching what they do. If they go this way or if they go that way, how much time they spend doing it. You're just observing them, and you're not doing anything to them to manipulate them. Whereas in an experiment, you're given some kind of treatment and you're looking at the reaction to that treatment. Now, in an experiment, you have a treatment group and you have a control group. Right now, they're doing experiments on getting a treatment for this COVID-19. They're trying to get some kind of treatment that we can not worry about this COVID-19. And they have all these people that they've signed up that they're given this treatment to. You have a treatment group and you have a control group. The treatment group is a group of people that are getting this vaccine, whatever it is, that they're trying to establish as the treatment for this virus. Then you have a control group that's not getting any treatment. They're getting what's called a placebo. A placebo is a fake treatment. So the thing is, you've got, you got all these people, all these 10 people here. Here's all these people in your group, and they're all getting medicine. They all think they're getting this pill, but only some of them are getting the treatment, and some of them are getting a fake treatment. This control group is getting the placebo, this fake treatment, which is nothing. And they're blind to the fact that they don't know it. And so what they do is they test the group and see what their reactions are on the treatment group versus the control group and see what kind of difference there is between them after the time period of this treatment. Now, the people that get the placebo, some of them will have this placebo effect take place, which means they're reacting favorably to the placebo, which placebo is a fake treatment. And they're acting favorably to it because they get this in their mind that they think that they're getting this treatment, and they make themselves feel like they're getting better or make themselves act favorably like the treatment group, when they're actually in the control group and they're not getting any treatment. So the treatment group gets the treatment, the control group does not get the treatment. They get a placebo, which is a fake treatment, and they think they're getting the treatment when they're actually not. And then you compare the two groups after. Okay? All right, we have different kinds of experiments and things. That we have it's called a simulation. That's just a physical model when you simulate something happening. You have a survey. That's when you investigate the population. You could call them on the phone. You ask them questions. They may do something online. But a survey is where you investigate what the population thinks or what they're doing. Then you have this what's called a confounding variable. That's when you cannot tell the difference between the effects of factors. That's factors right there. Now what this means right here, confounding variable. A confounding variable is when you have a treatment of some type, but you have something else that's also involved that might affect the group. And so you're not sure this confounding variable if that really affected it or if it's just a coincidence. Like for instance, suppose it rained on a day that you took this treatment. Okay, well, a confounding variable might be the rain. You might think that the rain caused you to get better. And some people think that. They think the weather might affect them one way or the other, when actually it might just be a confounding variable that's not affecting them at all. Randomization, when you randomly assign subjects to a treatment, you want to be random with things. When you have a group of people, you want to select them randomly, and so you have a general sample. You don't want this right here, bias. Bias is when you have some kind of favoritism or some kind of downfall in your survey, where it's not going to be a true representation of your population. Replication, I put a exclamation point here because this is important. Replication, repetition of your experiment. When you do this over and over and over and over, the bigger the numbers, the better the results. The more people you have involved in your survey, or the more people you have involved in your experiment, the better your results are going to be, and the more reliable they'll be. Then we have what's called a census versus a sampling. Census is when you count of the entire population and get information from the entire population, where a sampling, you just count of part of the population. Okay. All right, then we have simple random sample. These are different kinds of samples here on this page here. Every possible sample of the same size has the same chance of being selected. That's a simple random sample. So like when you're picking 5 people at random, every possible choice of the 5 people you select is possible. So like if I select these 5 people here, these 5 people, they have the same chance of being selected as 5 other people, or 5 other people that may involve 2 of those people. But every 5 people group has the same chance of being selected as any other 5 people group. That's a simple random sample. Versus a stratified sample. A stratified sample is when members from each segment of the population are involved. So like, say that 30% of your population is black. All right, a stratified sample would involve 30% of them should be black. Versus if you have like a 50% male, 50% female. Okay, your stratified sample would involve 50% of them being male and 50% of them being female. So that's when members of each segment of the population are involved. A cluster sample is when you divide the population into clusters and select all the members in one or more of these clusters. So like you have, here's your whole population right here. All right, so here's a cluster, there's a cluster, there's a cluster. And so you split this up into clusters. And then you might select this cluster here and select every member in that cluster and find out information about them to represent the whole population. Okay, a systematic sample is where each member of the population is numbered and every 5th, 100th, or 1,000th number is selected. So you number all these people, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 5 million or 20 million or whatever your number of your population is, and then you select every 5th person or every 100th person or every 1,000th person or every 500th person or whatever. You select each person in there. That's a good systematic sample of selecting people randomly. You can generate random numbers on a calculator. Like if you look at this calculator here, if you hit this math button right here, okay, and then go over to probability, okay, and then right down here, number 5, this is random integers. And so what you can do is, I can select numbers between 1 and, let's just do 12. Between 1 and 12. And I want 8 of these. Okay, so if I hit enter now, I'm going to get 8 numbers between 1 and 12. Bam, there they are. 1, 12, 2, 1, 7, 11, 12, 4. Look here, 12 got on here twice. 1 got on here twice. And that's what happens at random. Sometimes you get one selected more than once. But these are random numbers. Now, let me go to another page on here. Let's see. Okay. I think it's on this page. Yeah, right here. Now, here's a table of random numbers right there. These random numbers are generated. Okay? So what you can do is you could take these numbers and you can develop random numbers to choose from, or a population from this random numbers that's generated. So like these are all 5-digit numbers. Well, suppose you have 50 people. 50 people is all you have. All right, but then you can start, let's just say we're going to start here on this 4th row. Now look here, these are rows going sideways and these are columns going down. So if I start on this 4th row right here, okay, then my first, since I only have 50 people, I would need to split these up in 2s. So like my first one would be 31. See that? Then my next one would be 52. And then my next one would be 44. And the next one would be 95. Okay? And now 95 seems too much because we don't go in 52s too much because we only go up to 50, so I would take that one out. And 95 I'd rule out. Next one would be 87. I would put that one out because it's too much. 76, 61, and so on. Now, they did want an example down here. You can see now there's 731 students in this problem. And so they split this up into 3. So the first one is 719. Now look, they started right here in the third row down, and the second column, right here in this column, this number right there is 71966. Do you see it right there? That's what they started with, 71966. So 719, there's the first 3 numbers. They're doing 3 numbers because it's 731, which is 3 digits. Then the next 3 will be 662. Next one will be 738. 738 is too much, so that one's ruled out. Then 650, then 004, and then 053. And if you go in these numbers right here, now you can look this up on your computer yourself and see this better, but this is how numbers are generated randomly, how they're selected. Then we have what's called a convenience sample. A convenience sample is only members of the population that are easy to get a hold of, or those that are just convenient. Okay? So anyway, let me go over some of the problems that we're going to have in this. Here's number 1. Here's some things we're going to have, like right here. Okay? Let me see if I can... all right. We got to make it a little better. Okay. What's the difference between observational study and experiment? So you look in here, observational study is just a study. It's when you observe something. An experiment was when you give a treatment. So if we look now, here's the answer down here. Let's not look at the answer. Okay, we put it down here where we can't see it. You probably already saw it, didn't you? Anyway, an experiment, a researcher measures characteristics of interest of a part of the population but does not change existing conditions. No, that's not right here. That's not right. An experiment, a researcher measures characteristics of interest of an entire population. Okay, it's not entire population. Treatment is applied to part of the population. A treatment and responses are observed. In an observational study, a researcher measures characteristics of interest of a part of the population but does not change the existing conditions. This is it right here. Okay, like I was telling you, let me go through this again. An experiment, see right there the key word? You have a treatment. In an experiment, there's a treatment that's given. It's applied to part of the population, not the whole population, just a sample of it. And the responses are observed. In an observational study, a researcher measures characteristics of interest of a part of the population, but does not change existing conditions. There's no treatment given. So the answer here would be C. Okay, let's go to this next one here. Oh, let's not show the answer. Number 2, what's the difference between a census and a sampling? Now remember, a census is a whole population. A sampling is just part of the population. So a sampling is the entire population? No. Census includes the entire population. A sampling includes only part of the population. That's it right there, B. Okay. Number 3. What's the difference between a random sample and a simple random sample? Now we talked about a simple random sample. We didn't talk about a random sample. But I think the answer here is B. With a random sample, each individual has the same chance of being selected. With a simple random sample, all samples of the same size have the same chance of being selected. Okay, let me explain what that means right there. Suppose I have A, B, C, D, and E. These are my 5 people, and I pick sample. I'm going to pick a sample of 2 people. I could have A and B, I could have A and C, I could have A and D, I could have A and E, I can have B and C, B and D, B and E, C and D, C and E, and then D and E. All right, there's 10 different samples I could have. All right, well, each of these samples is equally likely to be selected as any of the other ones. So when you have a random sample, it's just individually they have the same chance of being selected. But in a simple random sample, all samples of the same size have the same chance of being selected. We're talking about the group itself. So if I select from these 5 right here, I select 2 of these 5, there's 10 different ones I could pick, and each one of these 10 has the same chance of being selected. That's a simple random sample. Okay? All right. Number 4 here. What is replication of experiment? Replication is when you do something over and over. Okay? Replication is repetition of an experiment under different conditions. No, we want the same condition. B here. Replication is repetition of an experiment under the same or similar conditions. Replication is important because it enhances the validity of the results. That's it right there. B. Replication is repetition of the same condition. You know, when you have, if you want to see if Tylenol is effective in giving, for people that have headaches, okay, you're going to give people Tylenol. You're going to give some people Tylenol and give some Advil. You're going to do the same thing because that's what you're trying to see about is the Tylenol. So you want the same conditions. Okay, and you do this over and over and over, and the more numbers you have, the better your results are going to be. Number 5. Determine whether the following statement is true or false. A placebo is an actual treatment. No, that's wrong. Placebo is a fake. Placebo is fake. So the statement is false. So it's not this one. Okay. The statement is false. So placebo is a fake treatment. That's it right there. A. Okay. Let's go to number 6 here. Number 6. Determine whether it's true or false. A double-blind experiment is used to increase the placebo effect. Okay, now we didn't talk about double-blind. Blind is when you give, remember you have a treatment group, all right. You have a treatment group and you have a control group. This one here is getting the treatment. This one's not getting the treatment. They're getting the placebo. Well, this is blind because these people don't know who's getting it, who's getting what. So it's a blind thing. All right, well, double blind is when these people don't know and the people that's giving them the treatment, they don't know either. See, what happens is if I'm giving these people the treatment and giving these people here the placebo, and I know who's getting what, then I could affect the results somehow because I know what's going on. Double blind, neither one of them know. So let's see here. A double blind, all right, here, I think the answer is A. This statement is false. It's used to increase the placebo effect. It's used to decrease the placebo effect. Placebo effect is when people react thinking they're getting the medicine when they're actually not. They're getting what's fake. See, because the placebo is a fake treatment. All right. So double blind is used to decrease the placebo effect where people react thinking they're getting the treatment. 7 determines if it's true or false. Using a systematic sample guarantees that members of each group within a population will be sampled. Okay. A systematic, okay, now it's not systematic, that's called stratified. If you remember now, let's go back to my notes here. Stratified. That's when members from each segment of the population are used. Stratified. So this should be stratified. I think it's C here. C, stratified. Okay, number 8. Determine whether it's true or false. The method for selecting a stratified sample is to order a population in some way and then select members of the population at regular intervals. Okay, that's not right, because see, this is stratified, which means you're going to get people from every group. Okay, so let's see here. The method for selecting a cluster sample. No, we're talking about. Okay, wait a minute. I see what it's doing. This is not stratified. This is a systematic way. So I think it should be a systematic sample is to order population in some way and then select members from the population at regular intervals. A cluster is where you put them in a cluster and you select everybody from that one cluster. Okay, number 9. In a survey of 1,282 adults in a country, 54% said the country's leader should release all medical information that might affect their ability to serve. This study is, well, it's an observational because there's no treatment given here because it does not apply treatment. So this is an observation and it does not apply treatment. Okay. All right, let's see here. Number 10. To study the effects of social media on teenagers' brains, researchers showed a few dozen teenagers photographs that had varying numbers of likes while scanning the reactions in their brains. This study, well, that's an experiment because they are giving a treatment and it applies a treatment. So this is an experiment that applies a treatment. Okay, all right. Now here's what we did a while ago. Okay. You see these numbers right here. Use the row of numbers shown below to generate 12 random numbers between 1 and 99. All right, so we want 12 numbers between 1 and 99. So these are 2-digit numbers. So what I'm going to do is I'm going to separate these in 2 digits. So I have 33. Then I have 07. Then I got 04. Then I have 46. Then next I have 75. Okay, then I have 16. Then I have 67. And then I would have 47 and 2 and then 30 and 61 and 6 and then 57, 10, 80, 23, 22, 83, 45, 13. That's how you would separate them off. But here's the first, well, it asked for the first 12, so I only had 7 blanks. But you can see here, I'm going to stop at that. You can see we got them going on here, 33, 7, 4, 46, 75, 16. You would enter those on the computer is what you would do. Okay? That's real simple to do. Number 12 down here, now I just did this on the calculator. What technology format could be used to generate 10 random numbers between 1 and 600? All right, so you're going to do the random integer. It's going to be between 1 and 600, so you should have 1, and then you should have 600, and then you want 10 numbers, so 10 would be next. And that looks like C right here. Okay. All right. 13, a pharmaceutical company wants to test the effectiveness of a new allergy drug. The company identifies 250 females 30 to 35 years old who suffer from severe allergies. The subjects are randomly assigned to 2 groups. One group is given the new allergy drug, the other is given a placebo that looks exactly like the new allergy drug. After 6 months, the subject's symptoms are studied and compared. Okay, now part 1. Identify the experimental units and treatments used in the experiment. Choose the correct answer below. Okay. The experimental units are 30 to 35, so it's got to be one of these two here. It's not B or C. 30 to 35-year-old females given the treatment. And the treatment is the new allergy drug. It's not for 6 months. It is 6 months, but the treatment is the drug, not the months. So the answer is D. The drug, the allergy drug, is the treatment, not the 6 months. Okay? Now on B, identify potential problem with the experiment being used and suggest a way to improve it. So like there could be a bias, a problem with that may make the numbers not exactly perfect. Okay, so let's see here. What could be wrong with this? A, there may be a bias on the part of the researcher if the researcher knows which patients were given the real drug. That is true there. If the researcher knows who's getting the drug, then that could cause a bias. So if the researcher does not know, that's called double blind. Remember we talked about that just a second ago. Let's see here. Choose the correct answer below. I think that's it. There may be a bias on part of the patients since they do not know if they were given. No, there's no problem there. No biases. There may be biases part of the experiment since only females are being tested. I think females are the population, so that is not really anything involved. So the answer is A. There may be bias because if the researcher knows who's given the drug and who's given the placebo, then he could somehow make it biased. But if he does not know, then there'd be no bias involved at all. The last one here, part C, how could this experiment be designed to be double blind? All right, double blind is when the researcher does not know. So that's what we want to look for here. When the patients don't know and the researcher does not know. So which one says that? If the patient knew they received the real drug or placebo, but the researcher did not know, that's not right. This would be double blind. If all patients received the placebo and no patient received the real, well, no, that makes no sense. You got to have some get the treatment. You got to have some get the placebo. The thing would be double blind if both the researcher and the patient did not know which patient received the real drug or the placebo. I think this is it right here. It's double blind if the researcher and the patient did not know which patient received the real drug or the placebo. That would be double blind. Okay. All right, 14 here. A researcher wants to study effects of sleep deprivation on motor skills. 9 people volunteered for the experiment. Amanda, Brian, Christine, David, Emily, Fred, George, Heather, and Ivan. Use the third row of digits in the random number table down here. So the third row, this is columns right here. This is a column right here, not the row. Here's the third row right here. Okay. Use the third row in the random number table below to select a simple random sample of 3 subjects. Ignore zeros. The other 6 subjects will go into the control group. If the subjects are number 1 through 9 alphabetically, what are the numbers of the 3 subjects selected? List the subject that will go into the treatment group. Okay. So, looks like we're going to start right here. 2, 4, 7. What's the numbers of the 3 subjects selected? 2, 4, 7. Okay. Now we could keep going if we selected more. 7 again, then 3, and then 1, 9, 6, and then we keep going. But we just want the first 3, 2, 4, 7. Now, the 3 subjects in order are what? What's the 3 subjects? Okay. Well, let's see. 2. Let's look up here now. 1, 2 would be Brian. So this would be Brian. Okay. 4 would be, let's see, 1, 2, 3, 4 would be David. Okay, and then 5, 6, 7 would be George. Okay. So what you do here for number 1, you would select which one would be, that would be Brian. So you would select Brian right there. And then for number 2, you would select David. And then for number 3, you would select George. Okay. All right, we're going to do a few more of these. Identify the sampling techniques used and discuss potential sources of bias. All right, we'll see some bias here. In 1965, researchers used random digit dialing to call 1,300 people and ask what obstacles kept them from attending town hall meetings. Okay, what kind of sampling was used? All right. So they're calling 1,300 people. They're calling them at random. So I think that's just a simple random sample. It's not a convenience. It's not a cluster sample. It's not systematic. It's just a simple random sample. Okay. Now, what biases are there? Well, I would tell you this. If they're asking, what kept you from attending the town hall meetings? That's kind of a bad question right there. Kind of a negative choice. So if you look at biases, I think that might be one, the question itself. Let's look here. A. Individuals may have refused to participate in the sample. This may have made the sample less representative of the population. That's true right there. That could be a bias because people may not do they may not participate. The sample only consisted of members of the population that were easy to get. Well, they called them at random, so I don't think that one's right. Individuals may have not been able when the researchers were calling. Have not been available. They were not. Those individuals that were available may not have been representative of the population. That's true there. If they don't get a hold of everybody on their random list, they may not have a true random sample. So that's a bias there. Part D, telephone sampling only includes people who had telephones. That's true. People who own telephones may have been older or wealthier on average and may not have been representative of the entire population. This is true. Some people may not have had a telephone, which means they're part of the population that's being ignored. Okay. Let's see, let's skip this one. Let's go to, this is 18. Identify the sampling techniques used and discuss potential sources of bias. Every 30th person entering a mall is asked to choose his or her favorite store from a list of 5 different stores that includes a description of each. So for a list of 5 different stores, they're supposed to choose their favorite one. Okay, so what type of sampling is this? Okay. I think this is systematic because every 30th person is selected. That's what systematic is. Okay, this is not convenience. It's not a simple random sample. It's not a stratified. It's not a cluster. Okay. What potential sources of bias are present? Okay, what kind of biases do we have here? All right, let's look at A. If there is a regular pattern to the people entering the mall, the people may not be representative. That could be true there. A regular pattern of the people that enter the mall. B, people who do not enter the mall are not sampled. Well, that's true there, but that's we're wanting to ask them which stores they like in the mall. If they don't go to the mall, then we won't ask them anyway. So that one's okay. It don't matter. The wording of the question may direct respondents towards a particular store. Okay. That might be true there because they have a list of 5 different stores. Which one's your favorite here? Well, their favorite may not be one of those 5. I think what would be better here is if they asked them, instead of giving them a list, write down your 5 favorite stores and then just had them write their 5, or have a list of all the stores and then have them choose their best 5 from all the stores instead of just this list from a list of 5 favorite ones. The favorite store, not the list of 5 favorite stores. So I think this one right here would be a bias. And there's no particular biases. Now there are biases here. See, a bias can change the data or make the data not accurate here. Number 19. Wheat is planted on a 54-acre field. The field is divided into 1-acre subplots. A sample is taken from each subplot to estimate the harvest. This looks like a cluster to me because you have all this field and it's divided into subplots. That's a cluster. So it looks like B. Okay, wait a minute. I didn't read the rest of this. It would be a cluster if all of it from that 1 acre, but see, here's what changes. Here's what changes. A sample is taken from each subplot to estimate the harvest. So that'd be stratified then. So I messed up there. I got ahead of myself. When they divide it into subplots, if they were to do all of them from that one subplot, that would be a cluster, but that's not what happened here. So this would be a stratified. The field's divided into subplots and random sample is taken from each subplot. Okay. What potential sources of biases are present, if any? Okay. Let's see. It's possible that due to sampling error, the sample will not be representative. Well, no, I don't think that would be. The sample only consists of wheat plants that are easiest to reach. This may not be representative of the entire population. It doesn't say they're only getting the ones that's easiest. They're getting subplots and they're going to get some from each subplot. C, certain subplots may have more or fewer wheat plants than others. Samples from these subplots may bias the. This is a good one here. That's a bias right there, because when you have your field and you got all these subplots in here, well, you have this one here, it may not produce as much as this one does. So that's going to make your numbers a little different. Okay, and there's more like this. Let's look at 21 here. Determine whether you would take a census or use a sampling to collect data for the study described below. If you would use a sampling, determine which sampling technique you would use. The average height of the 55 employees of a company. So what this tells me, the 55, that's all the employees there are. And since there's only 55 employees, you could just do a census here. So these are sampling. This could be a census here because it's only 55 people, and you could do that. There's not too many people involved for that. So population is small enough for it to be practical to record all the responses. Okay, 22 here. Determine whether you take a census. All right. The most popular actress among 90,000 online movie rental subscribers. All right, there's 90,000 here, so you would not do a census here because it's too many for that. So this would be a sampling. This is not a census here, so it can't be D this time. Okay, so it's got to be a sampling. All right. Now, which technique would you use here? The most popular actress among 90,000 online movie rental subscribers. Let's see here. The study would use stratified sampling because it would be important to have members from each segment of the population. I'm not really sure if it would matter about the different segments of the population, so I don't think this would be it. This one here, the study would use a cluster sampling because the subscribers fall in naturally occurring subgroups. Well, again, if you have a cluster, you got all these clusters here, and you would poll everybody in one of these clusters. But I don't know about these subgroups being different. I think the best would be to use a simple random sample. Just selecting people from these 90,000 people. I think the answer would be C here. That'd be the best way to go with this. And there's a couple more like that. I think I'll just maybe do a couple more here and we'll be done. About 23 here. Okay. Determine if the survey question is biased. If the question is biased, suggest a better wording. Why is eating eggs bad for you? All right, right here. That's already telling you that eating eggs is bad. So see, that's biased right there. It's already telling the person a negative thing. So the question is biased. Okay. So it's A, B, C, or D. See, these all say biased. This is not biased. Okay. So let's look here. Do you think eating eggs is good for you? All right, well, now here you're telling them that it's good. So do you think that eating eggs is bad for you? I think you're saying the words here and you're putting it in their head. So I think both of these are not very good. See the wording, how do you think eating eggs affects your health? I think this is good right here. Because you're not telling them the word good. You're not telling them the word bad. You're just letting them tell you what they think good or bad. And you're not putting anything in their head beforehand. So C would be your answer there. Okay. We'll do one more here, 24. Okay. Determine if the survey question is biased. How often do you drink soda during an average week? How often do you drink soda during an average week? Is the question biased? I don't think this one is. How often do you drink soda? See if it's still in there. Do you drink soda more than 3 hours? That would be biased. But this is asking how often do you drink it? So there's no bias here. Now, let's see here. Is it A or D? A, it's no because it does not lead the respondent to any particular answer. I think this is it right here. Look at D. No, because it influences the respondent into thinking that drinking soda is bad for you. No, it's A. It's A. Okay. So I think that's about all I'm going to go over with you on this. All right, so that's it for today, man, of data collection, experimental design. Now, if you have any questions over this, just let me know. I'll help you all I can. And please contact me. You know how to get a hold of me. And I hope you have a great day. Looking forward to hearing from you. Bye-bye.